Hello everyone, welcome to Big Boy Physics. Today in this video I have brought you with another problem from the topic of optics. Well, I didn't get it from any particular source, but I got it from one of the handouts I probably visited long ago. So I am explaining you the problem. The problem says that the medium or the region y greater than 0 is filled with some liquid of refractive index n, and y less than 0 is simply air, that is refractive index n is equals to 1. A person is standing on the x-axis and is moving along it and observes the position of an object which is kept in the frame with respect to the liquid at 0 comma h naught. The person is in the air, just you can say just below the x-axis. It's just below the x-axis. Okay, so the person is trying to see the object, but instead of seeing at a 0 comma h naught, you would expect that it will see the object to be at some other point, that is x naught comma y naught. Okay, so here say that x naught comma y naught is the required position of the object. Then we have to prove that x naught comma y naught satisfy the locus, that is a x naught to the power 2 by third, b y naught to the power 2 by third is equals to c, where a b c are in terms of h naught and n. Okay, so let's get started. We'll pause the video, then we'll start the solution. Hope you tried it for few minutes. Let's get started. Probably you may have remembered the Irodov question about finding the apparent depth in case of a variable angle or an oblique angle of viewing, rather than viewing it at straight angle. Okay. Similarly, in this case, we are interested with the x coordinate also, along with the y coordinate. Okay. So I am beginning the derivation from scratch, and okay, here's my picture. In this picture we can see that the horizontal distance between the person's eye and the x coordinate of the object is h naught tan I, where tan I is the angle of incidence. Okay, I is the angle of incidence and r is the angle of refraction. Now what will be the x distance, or the distance between the x coordinate of the object and the eye, will be h naught tan I, right? So one ray, that is the orange ray, which is I'm marking by some 1. So this ray 1 goes along the medium and hits the surface or the boundary, and then gets refracted at an angle some, let it be r. Okay, so it gets refracted at an angle small r. Then the ray will be produced backwards. Similarly, another ray will consider, which will be incidented at an angle I plus di, and it will be refracted at an angle r plus dr. Then you will similarly produce the second ray out of the means, or the backwards. Then it will meet the first ray, which is refracted and produced backwards at some other point. Okay, let it be point P. So I can say what is that first equation is n sin I is equals to sin r. Basically, my first equation will be the basic Snell's law, which will be n sin I is equals to sin r. Let me do with blue color because I already wrote the question in black color. So first equation will be n sin I is equals to sin r. Differentiating this equation, we are taking the differential. N is a constant. You will get n cos I di is equals to cos r dr. So this is equation 1. Now we will think, where will this equation get applied? Just wait and watch. Now we'll be using basic theorems or fundas of trigonometry. Observe that the tan I, what is tan I? Tan I can be written as h naught tan r can be written as h naught tan I minus x naught by y naught. Okay, so this is the basic expression of tan I. Similarly, tan r plus dr is equals to h naught tan I plus di minus x naught by y naught, because both the rays intersect at a common point, that is x naught comma y naught. So in this situation, we'll be taking x naught and y naught as constants, right? Instead of subtracting these two equations, we can just take the differentiation of this equation. We can just differentiate this equation 1 instead of subtracting equation 1 and 2. So differentiating, simply we will get sec square r dr is equals to h naught sec square I di by y naught. So I can say y naught is equals to h naught cos square r by cos square I. And what is di by dr? Di by dr is from the previous equation, that is cos r by n cos I. So multiplying with cos r by n cos I, you will get h naught by n cos cube r upon cos cube I. So this will be my expression for the y coordinate. Yeah, this was the equation which was asked in Erodov, right? So you have proved the first part, that is finding the y coordinate. Similarly, we'll be finding the x coordinate, just simplifying the equation 1. X naught will come out to be h naught tan I minus y naught tan r, right? It will be h naught tan I minus y naught tan r. Substituting the values, you'll get h naught sin I by cos I minus h naught by n uh, cos cube r upon cos cube I into sin r by sin I, so sin r by cos r. So one down, and cos square r, and well, just we need to do some more evaluations. Yeah, so sin r can be written as n sin I, just substituting it, n sin I, cancelling the n, and taking common terms, h naught sin I by cos cube I into cos square I minus cos square r. This is an interesting result. Okay, now just taking everything in terms of sin, you will get h naught sin I by cos cube I into sin square r. Now sin square r can be written as n square sin square I, so I can write n square minus 1 into sin square I, and finally you will get h naught tan cube I into n square minus 1. Now what I will do is that I will be taking whole to the power 2 by third both sides, left hand side and right hand side. X to the power 2 by third upon n square minus 1 whole to the power 2 by third is equals to h naught to the power 2 by third tan square I. Okay. Similarly, y naught to the power 2 by third is written as h naught by n to the power 2 by third whole to the power 2 by third actually into cos square, what is y naught, cos square r by cos square I. So it will come out to be cos square r by cos square I. Cos square r can be written as 1 minus sin square I. 1 minus sin square r. Sin square r can be written as n square sin square I. So evaluating this equation, h naught to the power 2 by third upon n naught to the power 2 by third into sec square I can be written as 1 plus tan square I. So I can write it finally to be 1 plus tan square I into 1 minus n square. I am not showing the detailed calculation. I am just writing what will be the final result after evaluating all those. Okay. Now just y naught to the power 2 by third into n to the power 2 by third is equals to h naught to the power 2 by third into 1 plus 1 minus n square tan square I, right? So we just did some separations of variables, and now what I'll do in this expression for x naught, for this is equation 2 and this is equation 3. So what I'll do, I'll be multiplying n square minus 1 both side in equation 2 and adding with the equation 3. So equation 2 plus equation 3, you will get n square minus 1 into x naught to the power 2 by third upon n square minus 1 whole to the power 2 by third. Probably this was the expression, right? Plus n to the power 2 by third y naught to the power 2 by third is equals to h naught to the power 2 by third. If we further continue the evaluation, we'll get n square minus 1 whole to the power 1 by third, x naught to the power 2 by third, plus n to the power 2 by third, y naught to the power 2 by third is equals to h naught to the power 2 by third. And we eventually proved that n square minus 1 whole to the power 1 by third as a, n to the power 2 by third as b, h naught to the power 2 by third as c will get the desired result. Yeah, this was a pretty lengthy and calculative question, but this expression will be very helpful for you in the upcoming methods of evaluation or getting ideas, or you may even get the direct question in any of your examinations if you are that lucky. Hope you enjoyed this video. Thank you. Have a nice day.